Hello, I'm Stefan Kleber. I'm the project leader for LXD. And in this video, we're going to be looking at what's new in LXD 5.0 LTS for those users who are currently on LXD 4.0 LTS. The previous video on this channel is the release livestream for LXD 5.0 LTS. And in that one, I went over everything that was new from LXD 4.24, which is the previous monthly LXD release. In this video, I'm going to instead be focusing more around what's new really in what are the big topics for those coming from LXD 4.0 over to this release, LXD 5.0. As an LTS release, it's going to be supported for 5 years. In this case, the end of support is set for June 2027. Up until then, you can expect the first 2 years to come with somewhat frequent bug fix releases, where we backport all bug fixes from our monthly releases. And after the initial 2 years where we do that, so up until the next release comes out, in this case LXD 6.0 LTS, the remaining 3 years of the support time is going to be primarily security updates. That means that for LXD 4.0, it's going to be getting one last bug fix release over the next couple of months, at which point it will go into that security only mode for the remaining 3 years of its support life. In the release announcement I've opened here, it begins with everything that's new for users of 4.24, but then below there's a section which is relevant here for those coming from LXD 4.0 LTS, and that's what we're going to be going over today, including a few examples here and there. As a reminder too, that's mentioned in the announcement, but we will no longer allow upgrading from releases prior to 4.0 over to 5.0. So if you're still on LXD 2.0 or 3.0, you're going to have to update to LXD 4.0 first and then upgrade to 5.0. That's so we can get rid of a lot of upgrade logic and code from the code base. So we're quite happy to do that. Now for LXD 5.0 LTS itself, and let's take a look at what's new. The first section I have here is around virtual machines. Virtual machine, our goal ever since the release of 4.0 effectively has been to get to parity between containers and VMs in many features, and we got quite a bit further with 5.0. That includes, in this case, support for VTPMs, much more options around PCI pass-through, support for stateful stop, stateful snapshots, and live migration, and support for hot plugging network devices, but also, as of 5.0 itself, disks and USB devices. We've also got support now in LXD storage to create custom storage volumes as blocks and then pass those into virtual machines. So as a first demo here, let's just look at some of those options. And for that, I'm going to be using a Windows 11 VM here. Now, the first thing would be to look at the TPM. So let's just, let's just load this here and look for TPM, which gets you into security processor on Windows. And those show that there is a TPM attached to this virtual machine. So yay, we've got that in LXD. You can look at the configuration in terminal below, and scrolling down to the config, you can see there's a device here that's of type TPM that's attached to the VM, and that gets you a working virtual TPM inside of the guest. In this case, that effectively lets LXD satisfy the requirement for installing Windows 11, and things just work. The other thing that was mentioned as far as new features is the support for hot plugging devices. So if we clear that and we go into here the device manager, and let's play with network cards, for example. So let's do device add Win11, and let's add a secondary network card connected to the same network. Network is actually called XCBR0, not default. And that got added, and here we go, it showed up in Windows immediately. For those kind of devices, we also support hot remove, so if we just yank it out instead, it's gonna disappear, and here we go. The same works with disks that we're going to be showing just a bit later, and with USB devices as well. So let's go back to the list. So that's primarily what I've got as far as demos for virtual machines. I'm going to skip over a lot of things in this announcement because the video would take forever otherwise. But I'm going to be linking to as many videos as I can because a lot of those different topics were covered in other LXD videos or in other release announcements. So I'm going to be trying to cross-link as much as possible so that if you've got any specific interest, you can go and find out more. The next big area of improvement in LXD 5.0 is networking. On the networking side, a lot of it was driven by us adding Oven, which is effectively an open source overlay network that's quite deeply integrated with the kernel through Open vSwitch that supports hardware offloading. It's very fast. It works really well. Supports a lot of features. Completely open source. Doesn't need kernel patches or anything. It's really, really nice. So we've added support for that in LXD, which has then unblocked a whole bunch of features. On the Oven side, that means that thanks to being able to create overlay networks, it's now possible to have networks within projects. So a project can own their own network. You can have two projects with the exact same network name, subnets, and everything, and they don't conflict, which is really convenient when dealing with like multiple groups of people using the same LXD server. Those networks, as I mentioned, can be accelerated, which means we support SIOV offloading to Mellanox network cards, especially the ConnectX-5, ConnectX-6 series, which effectively makes it possible to run those networks at 100 gig type speed by offloading just about everything to the hardware and just having the host system handle the first packet in every single communication. The other thing that we've added, still related to Oven, is the ability to have Oven networks peer with each other. So even across projects, you can effectively connect two networks together, and then they can access each other's networks without ever exiting the overlay, which again makes things really, really fast, and also lets you like reduce the amount of network traffic that would exit your system just to come back into it. Now, other features that were added on the networking side are ACLs. So effectively, they've got different names in different clouds, but it's firewall rules. It's being able to actually restrict ingress and egress traffic, both at the network level and at the instance level. So LXD has support for that. It's got a pretty full-fledged backend when used on Oven network, and it's got a much more restricted backend when used on normal bridge networking because of limitations of how Linux firewalling works. We also support what we call network forwards. Those are effectively floating IPs, but a bit fancier than what you might have elsewhere. So it's the same concept. You can add a public IP as a network forward, and then you can decide where it points to, so effectively NATing it to a specific instance. But LXD also supports doing it on a per port basis. So you can set that TCP port 80 goes to this instance, TCP port 443 goes to this instance instead. You can do those kind of things, which makes it quite flexible. We've got DNS support now. So you can create network zones within LXD, tie those to network, and then you get DNS records effectively generated for you. LXD operates as a very limited DNS server that supports zone transfer. And you can then get those zones imported into a proper DNS server to provide them to your users. This allows every single instance to have both a forward and reverse DNS record. Same thing for the gateways and other addresses that are managed by LXD itself. And the last thing I'd like to mention around networking is BGP support. So when running some pretty complex networks, especially when Oven is kind of involved, it's convenient to have all of your public subnets be able to just be routed straight into LXD from your routers without needing to put static routes in place. And so LXD supports doing BGP peering directly. It announces IP addresses for its networks, network forwards, and instances over BGP, setting the correct next hop so that your routers can send the traffic that LXD needs directly to the right machine without needing any static routes. So that's pretty much it for the main topics around networking. I'm gonna do a bit of a demo on some of those that I can easily show. So I'm gonna be switching to my main cluster. Here I go. And in this one, I guess if I switch to my core project and go look. So in this case, I'm now in a project. If we look at the networks here, we can see I've got 4 networks. They're all of the oven type. And now if I go look at another project, we can see that they have another network called the exact same thing, but with a different subnet. And that works perfectly fine. It really allows for individual project owners to do whatever they want, not really have to care about what anyone else might have done on the network. And those networks here, so in this case, I'm doing Anycast with 3 different Anycast networks, and I've got the primary network that I've called default for everything else. We can go look at peering for networks. So in this case, we can see that my default network peers with all 3 of the Anycast network, which makes it possible for instances across those networks to communicate with each other directly without exiting the network overlay. I also have ACL set up. So ACLs are also project specific. So in this case, I've got a whole bunch of them. I've got effectively a default ACL that's applied to the networks, which just allows some general traffic that I need. So like things like ICMP, access to DNS, access to a HTTP proxy, and incoming ICMP traffic. But then per service, I've got additional ACL rules that are applied. So say if we look at, I don't know, HTTP proxy, you're gonna see it's got a whole bunch of egress rules so that it can reach the different services that it needs to reach. And it's got a bunch of ingress rules to actually allow for the incoming traffic. In this case, it's the configuration used for the production image servers for LXD. So that effectively shows the peering and ACL side of things. Oven networks are effectively tied to an uplink, which is the network, the physical network that they get incoming traffic on. This is still in the default project. So if I switch to my default project over there and look at what's in there, this one will not show any other network. I don't have anything in that project, but it shows all the physical networks, including a network here that's called uplink. If we go look at what that looks like, we can see that it defines things like what subnet to use, what range Oven can use for its for the addresses it needs to allocate. Same thing for IPv6. And what I wanted to show here is that I'm actually using the BGP feature. So I've got a config option here telling Oven that instead of effectively responding to ARP and responding to the IPv6 equivalent, NDP, instead of having to do that, to respond to all the addresses that it's running, which would be quite a lot in my case, it's running in routed mode, so it can expect all traffic that it needs to handle to be routed to it. And to make that work, I have here a bunch of rules for BGP that defines 3 peers, which are my 3 upstream routers. LXD peers with them and announces all of the IPv4 and IPv6 addresses that are in use within LXD so that my routers know where to route the traffic. So that means that I can just go and like add any address I want or create any network I want with any public subnets that I want. And I don't need to do anything. LXD just automatically announces that, the routes get set up on my routers, and connectivity works. Specific projects can be restricted to specific networks. So if I go look at, say, this project, we can see that it's only allowed to use the uplink network called uplink, so that avoids any potential issue, and that it's allowed to use specific IPv4 and IPv6 subnets. So we can see it's got a single IPv4 address and it's got a /56 for IPv6. So anything within those ranges it can get access to and can use for its networks and its instances, and that will get announced also through BGP automatically. All right. So that's the networking side of things. Now switching back to web browser. There we go. That window. The next thing I wanted to cover is around storage. So we've added a feature called refreshes that makes it possible to copy an instance and effectively copy it again, refreshing its content. So any delta that exists, like any new snapshot or anything that changed, will just be synced again. So we introduced that since 4.0, and then 5.0 also supports an optimized version of that, so that it's even faster. I'm not gonna demo that particular feature because it's not super easy for me to do right now. But what I will show is the next one, which is a block custom storage volume. I'm gonna do that with Windows again. So if I go back to my VM here, and this time let's open the, what's it called? Yeah, this one, Disk Manager. You can currently see I only have one drive here. If I go to this one, let's just make it a bit bigger. There we go. And create a new volume. So let's see, storage volume create. In my default storage pool, let's call Win11 disk 1. Give it 20 gigs. And the new option is the file that we want it to be a block. So I do block, and then this storage pool not found. I'm not running against my local system, that's the issue. So we just reset that and then create. And now config device add Windows 11, call the device disk 1. It's a disk, the pool is default, and the volume is called Win11 disk 1. And here we go. So we see 20 gigs now showed up directly in Windows. So that shows two features that both shows the fact that we can create custom volumes that are block type, and that we can attach them to VMs, and that we've got the hot plug feature for disks working as well. Same works if I just remove it. So disk 1. And you can then delete the volume. So it's worth mentioning that volumes in LXD 5.0 can have snapshots and can be backed up exactly the same way instances can. So we've got support for all of that. Now going back to what's new. On the project side, there's also a fair bit that has changed there. We've got new options. So we've got resource limits to actually limit the amount of CPU, memory, and a bunch of other things that can be used by a given project. It's possible to restrict what machine within a cluster they get to use. It's possible to have a certificate in the trust store that's tied to specific projects. It's also possible to have other networks within projects. I actually showed that earlier. And on the resource limit, it's possible to get a usage report. And there's also a new feature that I've got a full video on that allows for LXD to dynamically generate restricted projects on a per user basis. And that's super useful, especially in desktop environments or corporate desktop environments. So for this one, the demo is going to be around resource limits and usage. So if I switch again to my remote cluster, we can go look at things here a tiny bit. So project, show, and sec. And we can see that this particular project, so it does have images, networks, profiles, and storage volumes all enabled. It's limited to a total of 4 CPUs, 75 gigs of disk, 4 gigs of RAM, 10 networks, 100,000 processes. And it's also then restricted. It allows nesting, it allows access to those specific networks, and it does allow snapshotting. To look at usage, you can do info on the project, and that shows the limits that are in place and the current usage against those limits. So that's pretty flexible. On the restricted certificate side of things, I can show that quickly too. if I look at the trust store here, I've got a bunch of certificates in them. 3 are for the servers, the cluster servers themselves. 1 is for Prometheus for metrics, but then I've got one called here NSEC Ansible. And if I go look at that config, oh, right, it needs to be the fingerprint. So, all right, if I look at the fingerprint here, we can see that it's marked as restricted and that it's tied to this particular project. So that means that when that client NSEC Ansible 01 connects, the only project that it can see is the NSEC project instead of seeing the entire list that I've got on this server, on this cluster. So that's another new feature and projects which makes it quite nice to use in like shared environments. For migration, we've got a new tool. So we used to have a tool called LXD P2C for physical to container. It was pretty limited, had a bunch of command line options, not super easy to use. We now have a new tool called LXD Migrate, which mostly takes over, adds a bunch more features, especially around authentication, but also supports migrating into a virtual machine instead of just into containers. So let's try to do a quick demo of that one. It's always a bit special because I don't have like a spare machine to try to suck in, nor really the time to do it. So instead, what I'm going to be doing is let's launch a container. Okay, so I've got a container called U1. I believe I've got the binary. Yeah, so let me copy the LXD migrate binary over to U1. Okay, then I'm gonna enter that container. Make sure that rsync is installed because it's a requirement for the migration tool. And I'm gonna pretend that this container is a actual system that I want to turn into a container on LXD. So I'm gonna be running the LXD migrate tool. It asks me to provide the server URL. In this case, I'm connecting. Yeah. I don't know if it actually wants a URL. I'm not sure if it wants a full URL, so let's do it. Okay, it shows me the server's fingerprint, and then it offers a few different ways to authenticate. So that's kind of new. Didn't used to be that flexible. In this case, we're going to be using the new recommended way, which is using certificate tokens. So to do that, I can do config trust add. Let's call it migrate. And that gets me a token here that I can use. So I'm gonna say user certificate token, providing the token, and it shows that it managed to authenticate. The remote server is on LXD 5.0, and it asks me whether I want to create a container or virtual machine. So in this case, a container. In the default project, let's call it U2, and then provide a path what I want to migrate. In this case, it's gonna be / because I want to migrate the entire container into a new container that way. No extra amounts. And the other thing that's kind of new is that you can actually go and perform a bunch of changes in overrides. So right now it shows that it would create an instance here, container using / default project. You can make some changes now. So say we want to go change. So the pool is still going to be default, but do you want to change the storage size? Sure. So let's say I want 5 gig. We can see now that it got those 2 lines added. And the same is true for things like networking or adding specific config options. So I could go and do specific options. So let's do 2 CPUs. And we can see that we now have 2 CPUs configured. Once it's all good, you can just hit enter. And it actually starts in using the migration API for LXD, transferring that over to your LXD server and creating the instance. So in this case, it's effectively going to make a copy of U1 as U2, which is not there are easier ways of doing that. But it's a good way to just test things locally. And if I start U2 and get a shell, it says it's called U1 because it is just a copy of what we just transferred here. So that's the new LXD migrate tool. It is quite a bit more user-friendly than LXD P2C. It really lets you kind of build up your entire config, use multiple authentication methods, move to VMs if you want, and then do the transfer at the end. It is much nicer than what we used to have. All right. So back to the list. And the last thing to go through is what we improved with clustering. So on the clustering side, well, it's quite a bit too. We've got failure domains, which makes it quite a bit easier. Well, it really tells LXD about the machines it's running on and what the physical world looks like and how it should manage its roles. So that is very useful, especially for the database. So it doesn't create situations where all of the database roles are placed on machines that are all on the same power feed, and then that power feed goes out and your entire cluster is dead. So LXD using failure domains can avoid that. We've got cluster evacuation, which makes it possible to evacuate a particular system that stops or migrates all the instances off, and then you can restore it and the instances come back onto it. Server groups allow for easy targeting and also restricting projects to a specific group of servers. And lastly, we've added, it's listed under clustering here, but it's actually available even without clusters. We've added support for a metrics API that can be used with Prometheus and Grafana to get like a nice view over time of the state of all your instances. So let's do a quick demo of those. On the clustering side, so let me switch to my home cluster this time. So here you can see that, I need to zoom out a bit. I've got 7 machines, and looking at the failure domains, you can see that a bunch of them have just their own name listed as their failure domain, which means that they're not really dependent on anything else. But 4 of them are listed with like somewhat matching failure domains. So we can see that Azuras and NTAC are both listed as APM chassis 1, Madrona and Verash listed as APM chassis 2. That's because they are physically inside the same chassis. It's 2 different physical systems in the same chassis with a single power supply. So if that power supply dies, they both die. And setting the failure domain that way means that LXD will not place, will make sure that the roles are balanced as much as possible to avoid those kind of problems, which we can see here. So the database leader is on APM chassis 1, but the other 2 database roles on 2 other machines. Like there's no situation where like that chassis would go down and database would die. The other thing we can see here is actually have cluster groups as well, with a number of machines in them. So we can do show on, say, lab, and see that the lab has 2 machines, the core has 4, and that lets me do, show what project I'm in. Okay, I'm in my demo project, that's good. So I can do A1, and I can do something like lab. And that will create an instance targeting one of the machine that's listed within lab, instead of just dispatching it to whichever has the fewest instances right now. My cluster is entirely based on Ceph, which makes the initial image impact be slightly slower than would be ideal. So in this case, we can see it picked Delmac, which is one of the machines within the lab. And the last thing I want to show is Grafana. So let me just go back to a web browser for that. Go. All right. So say we switch to Montreal. Could look at demo, but it's not going to be super busy because literally an instance started just a few seconds ago. But we can load some project in here, and that's the Grafana dashboard that uses our new metrics API. And you can see you can look at multiple deployments by looking at the Prometheus job name, and then drill down per project, and you can then either drill down per specific instance within the project, or you can just look at the project overview. So in this case, it shows me my top CPU usage, memory usage, the disk space usage, the overall use for disk and network on the entire project. And then you've got a number of graphs to also look for anything potentially problematic. So you can look, in this case, it's network errors or packet drops. You can go look at that, see if there's some kind of problem somewhere. And if you want to drill down onto a specific VM, you can go and expand it, and then you'll see what's going on. I'm saying VM because this project only has VMs, but if you open a project that has containers, then you get kind of the same view, but this time with containers. So you can go look at CPU usage, memory, processes, network. That makes it very easy to debug things because you can look at the overall usage of a given project, see if there's anything that looks weird. Like for example, you could be wondering, okay, what happened at this particular time? There was a big spike in CPU, and you could go and drill down to the specific timeline here, and then go look at, okay, did we see a memory, some kind of big memory allocation at that time, or was there a matching? Like in this case, there was a spike of processes and then it went down. Is that somehow related? It makes it really easy to go and debug. I mean, in this case, we can see that the network traffic kind of lines up pretty well with the CPU usage. So that's probably what happened. But yeah, it's a very useful debugging tool. And with Grafana, you can also set alerts on things like your disk usage. So you could get an alert trigger automatically if you're reaching some specific value of disk usage. And well, that's it really for the big highlights in 5.0 for those of you coming from LXD 4.0. I'm gonna try and put as many links as I can to different videos that showed up over like we published over the past few months that show a lot of those new features, as well as to some of the release live streams that have happened in the past that also go through those features. I didn't want to go through every single new feature for those coming from 4.0 because that would take way too long. But I thought I would pick kind of my top pick and do a few demos here and there, and just drive you through like the main highlights for this LTS. I hope you're going to be upgrading to LXD 5.0 soon. It's really a great LTS, supports a lot of features, and we're really happy with it. And yeah, if you've got any questions on any of it, you can leave them down in the comment section below, or go on our community forum and ask there. And I'll see you all in the next video. Thank you.